I have talked about air pollution and poverty relation before in other contexts. Here we are going to look at it again because there's a new paper that just came out as I'm recording this in August 2023. So, global air pollution exposure and poverty kind of confirms what we already know, but it's worth looking at them again to remind ourselves. I'm always confused when we are so focused with a tunnel vision on carbon mitigation, global warming targets, we often forget that the number of deaths from natural hazards typically is less than 1% in most countries and globally, whereas deaths from cardiovascular diseases is as high as 30% in most places. So air pollution is not directly global warming. They are related. Economic activities, human activities, land use, they are related to air pollution, and yet combating air pollution doesn't get not nearly as much attention as this massive focus on global warming targets. Climate change is a serious issue, and climate adaptation is required as well as mitigation, but mitigation somehow is easier in terms of focusing on carbon capture and renewable deployments and so on and so forth. So somehow this is always muddled in my mind as to whether we are completely being focused on saving lives, in which case air pollution should be a bigger focus, and so on. Okay, so you make your own judgment on that. Air pollution is one of the leading causes of health complications and mortality worldwide, especially affecting lower income groups who tend to be more exposed and vulnerable. This study documents the relationship between ambient air pollution exposure and poverty in 211 countries and territories. Using World Health Organization's 2021 revised fine particulate matter thresholds, we show that globally 7.3 billion people are directly exposed to unsafe average annual PM2.5 concentrations, 80% of whom live in low and middle income countries. 80% live in low and middle income countries. Often these activities in these countries producing pollution are something to serve the richer countries, because the richer countries have outsourced many of the manufacturing processes to the low and middle income countries, for example. Moreover, 716 million of the world's lowest income people living on less than $1.9 per day live in areas with unsafe levels of air pollution, especially in sub-Saharan Africa. Air pollution levels are particularly high in lower middle income countries, where economies tend to rely more heavily on polluting industries and technologies. These findings are based on high-resolution air pollution and population maps with global coverage, as well as sub-national poverty estimates based on harmonized household surveys. So it's a nice analysis in that sense. We are looking here at this figure, global population exposure to unsafe air pollution by region and risk level. Here global population headcounts exposed to different levels of air pollution risk. So we are talking about world population at no risk, low risk, moderate, high, and very high risk in this color, and the darkest of the blues here is hazardous levels. So we are looking at 14% at no risk, 15% at low, 18 at moderate, 10 at high. Sorry, let me make sure. There is nobody at no risk. Okay, sorry. Low risk, moderate risk, high risk, very high risk, and hazardous. People living in hazardous risk is 2.8 billion, so that's 36% of the population. And if you look at different regions, you have unsafe and hazardous levels covering a lot of the population. Okay, so you can see the codes for these different regions. I'm not going to mention here, but Middle East and North Africa has 92.8% in hazardous levels. USA and Canada have 91.8% at unsafe levels. Latin America and Central America have 82.2%, 534 million at unsafe levels, and South Asia, see South Asia is here. 76.4% is unsafe and 15.5% is at hazardous levels, and so on. Okay, part of the same figure, looking at China, India, and United States. Down the line, China is the highest population that is either at unsafe or hazardous level. It's basically all of the population. Similarly, India, even higher, a tiny bit higher. A very small fraction is at unsafe level, and basically majority of the population at hazard level, has hazardous exposure to PM2.5, and US has got unsafe levels of exposure at 92.4% and so on. And we know that PM2.5 can get into bloodstreams, guts, even brains. Dogs on the streets have been found with PM2.5 in their brains. It's responsible for not only cardiovascular diseases but diabetes, low performance, mental disorders in many cases, gut microbiome affected, and so on and so forth. PM2.5 exposure head counts at different poverty thresholds. So you just look at the numbers and you will see poverty threshold in consumption per day. $1.9, there is 760 million. If you raise it to 3.2, then you get more people living in the poverty threshold, and of course if you raise it to $5.5 per day, that's actually in India would be a fairly decent living. For example, you get 3 billion people in exposure head counts. Okay, share of the population, global population that lives in poverty, number of people that live in poverty are exposed to. So if you take these and then look at how many are exposed to unsafe levels of PM2.5, 716 of the 768, almost all of the ones living at $3.20 and $5.50, about 2.9 billion, let's say, out of the 3 billion or so. So basically pretty much everybody is living at either unsafe or hazardous levels when they are in the poverty limitations, or in terms of per capita per day income. Okay, so share of the population that lives in poverty and exposed to hazardous PM2.5 levels is 3.5 for this income level, 12.1 for this, and 20.3% for this income level. So this is looking at exposure to unsafe annual PM2.5 concentrations as a share of the population. So in A, we will see percentage of population exposed to PM2.5 of over 5 micrograms per meter, percentage of population exposed to more than 15, and this is more than 35. So you can see that there is no safe air to breathe. So pretty much the entire globe is at more than 5 milligram per meter cube of PM2.5 levels, except in very remote areas where people don't live, or in Tibet here, and western parts of Australia, and parts of South America here, and the northwest corner of US and Canada. That's basically all of Canada there. But if you look at 15, then you see that number drops, but we know that 5 is already pretty bad, and we will see the WHO standards at the end. I put it at the end because we want to get a sense of hazardous and very hazardous levels of exposure first. So most of the global south is in here in terms of exposures to very high number of people being exposed to greater than 15 micrograms per meter cube of PM2.5. If you increase it to 35, then India unfortunately remains. Almost all of India is exposed to more than 35 micrograms per meter cube, and there is large percentage of China and Central Asia here, and eastern seaboard of China is exposed to almost all of the population is exposed to PM2.5 of greater than 35 micrograms per meter cube. You can also look at it in terms of healthcare access and quality index. So this is various countries. We will look at C first and then come to A and B here. So air pollution exposure of people in poverty. So A and B will look in the next slide. In C, basically we are looking at healthcare access and quality in countries with high air pollution and poverty. The healthcare access and quality HAQ index is by GBD 2019, healthcare access quality and collaborators. Okay, so I won't go into the details, but you can look this reference up. So share of population in low income and exposed to unsafe air pollution in percentages. So you can see the usual suspects are up here with low healthcare access and quality index as of 2019 metrics. So you have Central African Republics, South Sudan, Burundi, Guinea-Bissau, and so on. Haiti, so lower number of people exposed to air pollution and living in low income, but you can see that the HAQ index remains low. So only when you get towards this scale, you have HAQ index being high and share of population living in low income being low, which is not surprising. As the number of poor people drops, those are richer countries. South Korea is up here, United States, Germany, France, sorry, South Korea is here, Japan, Sweden, Iceland, and so on. With Iceland, for example, has the highest HAQ index and has basically very low number of people living in low income, or maybe even 0%. Okay, so a lot of these are good. We are very close to 0% here, but you can see that Mexico, Brazil, Vietnam, and so on are also here, and India is up here, and China will be somewhere. You can find China as well on this one. If we go to A and B, number of people living in poverty and facing unsafe air pollution exposure at different poverty thresholds and by region, and top 10 countries, percentage of people living on $190 per day and exposed to hazardous PM2.5 levels. Okay, so as we said before, 550 per day, 320 per day, 190 per day. The number of people fortunately is low that are living in less than $2 per day, but the number of people living in at 320 per day and 550 per day is quite high. So that's population in billions from different regions. Okay, and these are the exposures we talked about by different regions. So Congo, Togo, Benin, India, Nigeria, Congo, and so on, and you can see the numbers. They are not very comforting, let's say, in terms of billions of people that are exposed. Looking at another figure, regional distribution of air quality and poverty. So again, we'll start by looking at C. I do this way because the caption is under the last panel, and then the figure is too large to fit into one slide, so I just split them randomly. Sorry about that. Share of the population exposed to unsafe PM2.5 levels and living on less than 550 per day. So you can see 80 to 100% of the people in these dark red colors, and then lower numbers as you go to lower colors. Again, Africa and India light up here, and China is not in this bin. But if you go to the next level here in terms of share of population exposed to unsafe PM2.5 levels and living on less than 190 per day, and share of population exposed to unsafe PM2.5 levels and living on less than 320 per day. So each one of the figure is showing people living on, let's say, extreme poverty less than 2 per day, low income at 320 per day, and medium, I don't know, it's still low income poverty at 550 per day. Okay, so you can see that India drops here and China begins to light up, and China disappears here again. So China is somewhere in people living under 320 per day and exposed to unsafe levels at 8 to 24%. The Indo-Gangetic Plain and Northwest India, the breadbasket, generally not so heavy in rainfall, heavy in agricultural activities, maybe deforestation happening and so on, industrial belt, etc., live on less than 320 per day, and they are exposed to unsafe levels of PM2.5, and this is a mixed bag here. We always focus on sub-Saharan Africa, but you can see Central and South Eastern Africa are pretty bad as well. If you go up to 520 per day and unsafe levels, Africa has got many people that are better off in terms of income, but also exposed to unsafe levels of PM2.5. Just confirming the things we have looked at. This one has 4 panels, so I have taken D first. Global population exposure to PM2.5 concentrations. Here we are going at over 5 milligrams per meter cube, 4% increased mortality rate. And in D we have regional distribution of mean PM2.5 concentrations. So just looking at concentration thresholds, and estimated mortality rates are based on the WHO Global Air Quality Guidelines, which provide the details on estimation methods. Low income LIC is low income, LMIC is lower middle income, UMIC is upper middle income. So, and HIC is of course high income countries. So D here is again regional distribution of mean PM2.5 concentrations. India and parts of China are fairly bad. Pakistan is fairly bad. Sub-Saharan Africa here, Western Africa and Central Africa are pretty bad. Rest of them, are they good? Well, they are still way above. Let's say if 12 microgram per meter cube is safe, then most of the world is living in close to unsafe levels of air. Looking here at over 5 microgram per meter cube exposure and over 10 microgram per meter cube exposure. This one comes with 4% increase in mortality when you cross the 5 microgram per meter cube threshold, and the mortality increase rate jumps to 8% when you go to 10 microgram per meter cube. Again, number of people, billions from different regions living in greater than 5 micrograms or less than 5. There are tiny fractions living in less than 5 micrograms per meter cube exposure, but that also may mean that the low income there is happening in a cleaner air, because they are probably living in remote places, forests, mountains and so on, whereas the others, poor people living in human activity or natural occurrence of dust and so on, with like sub-Saharan Africa or Mongolia and the Middle East, where you have higher PM2.5 and lower income for some share of the populations. Okay, so I won't go too much into the details. These are the different regions, number of people, that's the population, and population share in terms of percentages, and this is for greater than 10 micrograms and this is for greater than 35 micrograms per meter cube. So numbers are alarming and not at all comforting when you consider the increased mortality coming even at 5 micrograms per meter cube and increasing, doubling at 10 micrograms per meter cube. These are some details. PM2.5 concentration in Southeast Asia. So this entire region is covered, Southeast Asia actually. Estimates represent annual average concentrations in 2018, constructed based on satellite-based remote sensing data, global chemical transport modeling, and ground measurements. So this is another problem. Estimating PM2.5 concentration is tricky, especially if you do annual means. What does it mean? Because there is very strong seasonality in this region because of the monsoonal circulation, and the aerosol loading and PM2.5 concentrations can be very different. So what is the background level throughout the year and how it spikes? If this is on the annual mean so high, or close to 50 to 150 micrograms per meter cube, then when it is spiking, let's say in the crop burning season, how much higher is it? So that's really something to worry about as well. Finally, looking at PM2.5 concentration thresholds based on the WHO Global Air Quality Guidelines, safe with no or minor risk has to be less than equal to 5 micrograms per meter cube. That's why we use that threshold. And increases in mortality rate, if we take this safe and minor risk level as the baseline. Note that we have put minor risk here, so it depends on how sensitive you are, and it's age dependent. So little kids may be sensitive, older people may be sensitive. Excuse me. Unsafe levels low, so jump in mortality is 4%, moderate 10 to 15 micrograms per meter cube, it's 8%, high you get to 16%, very high you flatten to about 24%, and hazardous levels of greater than 35 micrograms per meter cube of PM2.5 concentration increases the mortality by 24% compared to the baseline. Now you combine that with the maps we looked at, a number of people exposed, and you combine with the fact that when we talk about low middle income people, then they don't have air conditioning at home, so plus they may be burning biomass for cooking, so indoor exposure will be high as well. Here we are only talking about outdoor exposure, so there are confounding factors we have to worry about. So I kind of gave you a very brief summary of this paper, which I think is very important, but I always keep the podcasts short enough so that if you want to follow up, you can go and look at it, look at the original paper, and they have a very long list of citations which are very relevant as well. Okay.